So anyway, I was saying I came to California. I've spent a few days on vacation and now I'm here. I hope this is going to be the most enjoyable part of my visit to California this time. Now, when Francesco asked me to hold a presentation, I immediately said yes, as I said, and then the next thing I still thought, I wonder what he wants me to talk about. And the next thing I asked Francesco, what do you want me to talk about? And he said, well, find something interesting to say. Now, the problem is, as I said, that I've been working in management for 25 years, and as you know, the first thing that happens when you go into management is they amputate half your brain. So that was a bit of a problem, and then I haven't done that much programming during the time. I've been keeping my hand in. I wrote a tutorial about Erlang, but I haven't actually been doing any large-scale programming. So I thought, what can I talk about? And I thought, well, I know what I'll talk about. I'll talk about the esoterics of how you design mobile cellular radio base stations. And I thought, maybe, no, I don't think they want to hear about that. And then I said, oh, well, just having retired, maybe I should be a bit philosophical and talk a bit about history. And I thought, well, I'll tell them all about paper, tape, and punch cards and that sort of thing. I thought, no, they don't want to hear about that either. So I finally thought, well, what do I know about? And I said, well, actually, what the lot I do know about is how you manage software projects and how not to manage software projects, because I've had some successes and I've also had some disastrous failures. So I thought I'd tell you a bit about that and my view about that. Well, I spent 20 years working as a programmer, both in the computer science lab when we invented Erlang, and prior to that I just worked as a norm programmer. I actually started programming the first time in 1967. Which I regret to say is probably before most of you were born. But 20 years programming, and I used to wonder, when these managers that hang around here, they don't seem to understand what we're doing. They're completely nuts. They've no idea. And I said, well, I wonder why. I wonder why they don't understand. So I decided the only way to discover why managers don't understand programmers was become a manager. So I did. So I spent 20 years working with a manager, and I wondered why programmers didn't understand managers. There are several reasons for that, and that's basically what I'm going to try and talk about today. I'll try and make it a bit Erlang-y at the end, but as I work with all sorts of things, from assembly language to C++ to Java to even horrible things like UML. Don't do that. But since I work with that sort of thing, I thought I'd try to give you a broader perspective and sort of zoom in a bit on Erlang towards the end of my talk. So, what's programming about, and why is managing programming projects so difficult? I mean, it should be just like sort of building a house or construction industry or whatever. I mean, what makes programming so difficult, and why are so many programming projects are totally unpredictable in the sense that they very seldom underrun. They very seldom use less than their budget. They very frequently use 10 times more than their initial budget. What's gone wrong? Why can't we predict what goes wrong? Why are things late? And there are even books. I bought a book not long ago about disastrous programming failures. There are more books, I think, about programming failures than there are about programming successes. So let's start with, I've shown some of these slides before, so some of you may recognize them, but I'm a great believer in reuse, so I've done them again. That there are three fundamentally different types of programming project. You're doing something the first time. That's you're building something new. I'll get back to a bit more about that. And that is that's what everyone wants to do. That's what all good programmers want to do. They want to do something new. And then unfortunately, if they want to earn any money, they have to go to stage 2 and make a product. That you don't sort of make much money from wild ideas. Hello, Robert. Yeah. Then when you've actually got a product, if you want to continue making money, you actually have to maintain it. And these products, these types of project are fundamentally different from each other. And this is the first reason that managers get things wrong. They don't understand that there are three different types of projects. They try to make a product in the same way as you would do a sort of you try to develop something the first time in the same way as you would actually try and make a product. Getting onto that, and what are they? Well, the first type of project, developing something the first time, this is bold, wild experiments, testing our implementation, testing architecture, throwing away code. You know, something that managers hate, that a programmer says, oh, I didn't get that right, I'll throw it away and do it again. Well, doesn't it work? Why didn't you get it right? They tend to, there's almost a blame game for trying to get for people who want to throw away code. People don't like that at all. Managers don't like that at all. Programmers like it. You have to get things right. Then you're making a product. Well, when you're making a product, you hopefully have got a sort of fairly good idea about what you're doing. And you're filling out a tested architecture, and you know you hopefully have got a good idea about implementations, although sometimes you have to go from making a product to the first type of project backwards and forwards a few times. And this is difficult because maybe you started the first stage with 5 or 6 people doing something together, and then you start making a product and you scale up to 50, 60, maybe in some projects I've been involved with 600 people. And then you say, gosh, we got that wrong. And you can't actually go from 600 people back to the 5 or 6 people very easily. That telling 595 people to sit around twisting their thumbs for a few months while you work it out again is not generally popular. Then you actually get to the other stage, maintaining a product. Now, this is people who maintain products are a very special sort of programmer because they're the sort of programmers that really enjoy finding bugs. Most programmers hate finding bugs, but enjoy finding bugs, messing around with things, trying to get things, correcting things. It's a very special skill, and I think it's a very underestimated skill. That some of the best programmers are actually maintainers, but that's something which is not generally recognized. And unfortunately, a lot of the good programmers, they want to do the first thing, they want to develop things for the first time. So it's difficult to get good people to do maintenance, but it's very necessary. Okay, difficulty. What's this about? Well, there's a little sort of 4 boxes. Suppose you know how to do it and you know what's wanted. Well, that's easy. It's easy to run that sort of project. There's no problem at all. But on the other hand, if you know how to do it and you know what's wanted, that means someone's done it before. So why the heck are you doing it at all? You download it from somewhere or steal it from somewhere or whatever you're going to do. But you shouldn't really need to be doing that sort of project. And then you have the type that you know what's wanted, but you don't know how to do it. Well, that's difficult. Sometimes you need, a good example of that is when you have a nice system which is running on a non-multi-core system and you want to make it run on a multi-core system. Of course, that's trivial in Erlang. But on the other hand, try and do that in C++. Well, you're in deep trouble if you try there. You really have to work out how to do things again from the start. If you haven't got concurrency in your system and you're trying to put concurrency into the system, that's difficult. Sometimes you don't know what's wanted. And there's always people who think that they can make nice, beautiful specifications and get it right. But it doesn't work that way. Sometimes you actually have to start programming to work out what's wanted. And then, of course, you've got the state, okay, which it happens very frequently, that you neither know what the customer wants or what you're trying to do, or you know how to do it. That's very difficult. And a lot of projects come into that sphere, but don't think that you shouldn't be doing them, because that's the sphere probably where you can make most money. Working out what to do and working out how to do it. I think that is where a lot of the real innovation comes in. So don't knock that idea. Then predictability. That, well, again, that if you know what's wanted and you know how to do it, then it's fairly easy, fairly predictable how to do it. And you don't really have to think about that. And as I say, hopefully you can download what you want from the net anyway, because someone's done it before. you know what to do, and but you don't know how to do it. Well, that's not too bad. It's fairly predictable, because you do have to do a lot of experimentation, but you can work out roughly what to do. And then you get the state of affairs that you know how to do it, but not what's wanted. Now that's very unpredictable, because by the time you start doing things, you're going to find you're not doing what the customer wants, you're doing something different. And you have to go backwards and forwards. And then of course you get the final, you don't know what you're doing, and you don't know how to do it. That is highly unpredictable. And it can take you years and years and years of work, or you might do it quickly. You have no idea what's going on. But there again, that is a very important area. Now, I got back to management. The difficulty is that if you look at these two matrices, I don't think most managers in the software industry actually understand these matrices. They always think that you're actually in square one, that you know how to do it and you know what's wanted. Oh, we've written the spec. They said, oh yeah, you've got a programming language, well go ahead and do it. It's not that easy, but a lot of managers think it's that way, and that is one of the major reasons for the programming disasters we have today and things that don't work, that people haven't realized what sort of project they're doing, what sort of team they need, or they can't predict it. Well, what's this all about? It's all about? Well, this is the fundamental. This is where I start trying to get philosophical. That I'm getting older, and I retired about 2 years ago. And the older you get, the more philosophical you get. So I said, what's programming about? Well, programming is about trial and error. And if you don't believe that, just think about the most trivial thing you do when you write a program. You put it through your compiler and let the compiler spit out the syntax errors. You don't actually spend half an hour looking at your code to sort of to get rid of the errors. You put it in the compiler, and that's trial and error. You correct the syntax errors, and off you go. And then when you start running it, it crashes, and you just find out where the crash is. That's what programming is about, trial and error. And if you don't know what's wanted, trial and error is the only way of finding out. Just try it out. Is this right? Show it to the customer. If you don't know how to do things, trial and error again. Again, often knowing how to do things is a question of optimization, making your software run fast enough. And again, the only way to get things to run fast enough is to have theories about how things work, to make measurements, find out where your bottlenecks are, and go ahead and do things like experimentation. Now, trial and error is unpredictable, and there again we have a question about why managers don't like it. If you sort of go and tell your manager, oh, I don't know, because I haven't tried it out yet, the manager somehow thinks, well, you should know. And at the same time, you get managers who say, well, tell me how long this is going to take. I don't know, I haven't tried yet. And is anything a programmer really hates is trying to predict the unpredictable. And that's one of the basic reasons that programmers don't understand managers, and managers don't understand programmers. Well, this is a sort of a waterfall model which we've all seen and we've all sort of done. And this is the way some people think that things work. And a lot of managers who have probably written a few sort of lines of C or Java at school and then have never done anything else, think this is the way it should be. Because when you do things by yourself in a one-person project, it's very, very different from a multi-person project. And there are a lot of managers who still think you should be able to run a project by the sort of waterfall method. I'd have thought that one thing which has come in nowadays which is helping this sort of idea is the idea of agile programming, things like Scrum. That when I first heard of Scrum, I thought the idea of putting a lot of yellow sticky labels on a whiteboard and trying to work things out from that sounded crazy. But then I actually looked at it in practice, and it is actually a very good idea. And I think that Scrum is really, and Agile Programming is really a way that programmers are finally getting their revenge on stupid managers. That, so I hope that, well, predictability. Well, I know no really good model to predict things. I don't think there is a good model to predict things. if you're enhancing an existing product, then you know roughly what's going on. I can give an example there. When we first started making radio base stations, we had a small team of people doing things, and we didn't really know what was happening. But nevertheless, we knew that, especially when we were doing the 3G systems, we knew we had to get things out there fast. And it was a typical sort of normal mess at the start, which was right. It should have been a mess. Lots of people working, lots of people doing things in parallel until we sort of finally fleshed out what needed to be done. Then at the later stage, when we got the 3G system working, we had a team of, I think there were about 600 people working with the software of radio base stations, and people don't really realize often how many people work in the mobile telephony, the cellular telephony programming. Probably one of the largest programming projects in the world. Well, of those 600 people, we could actually, when we'd actually got the framework, we could predict things fairly well. It was only when we were going to introduce something completely new that we finally found that the things were going wrong. The first generation of 3G could manage fairly slow data speeds, and then we introduced packet data. And that really revolutionized things, and that caused a major hiccup. But when you're actually doing things like sort of changing things like, well, very simple bits of software about how you tilt an antenna on the top of a radio tower, that's easy to predict. You can work that out fairly well because you know roughly what's going to be done. It's been done before. There again, a lot of managers don't see the difference between new development and enhancement of projects. That one of the most disastrous projects that I was involved with, which spent an awful lot of money, you can ask Robert about that, he knows about that too. The first generation of telephony made by Ericsson was made successfully by a small team of people, which was scaled up to about a couple of thousand people when it was at its height. The people who was after a bit said, well, we need a new system, we need to make things a bit better. So the way they did this was they started off by employing about 1,000 people to do the system. And that was a complete mess, because you cannot start a new system with that number of people. And it's sort of, I think it probably is one of the most major programming disasters in Ericsson's history. I can talk about these things now because I'm no longer employed by Ericsson, they can't fire me. But I'm not going to talk about it in detail, but it was incredible. It was, we sat at that time developing Erlang in the computer science lab, scratching our heads and said, what are these guys doing about? In fact, they produced more Word documents, or I think it was probably FrameMaker they used at the time, they produced more documents on paper than they actually produced lines of code which did anything useful. It was amazing. There are, thank goodness, a lot of sensible managers, like me, of course, but I have to be modest occasionally. There are, unfortunately, a lot of managers who have very funny, strange prejudices. And there are a lot of managers who've drifted into management of software that know nothing about it. And these are some of the observations I've had over the years about programmers, and managers and the attitudes of managers. One of them is that bugs are evil, the sign of lazy, sloppy programmers. That people who write code with bugs in it should be punished. There are people that really seriously think that. And I think they sort of don't realize that maybe the programmer that was doing this bit has got a hard bit of code, he's doing the difficult bit. And that maybe it's quite reasonable to think that there are more bugs when you do the difficult bit than the easy bit. Another one, and this I've heard very frequently, is that programming is a very small part of software development. Software technology and programming languages are irrelevant. I've heard that said lots and lots of times. Coding is only 5% of the time we do the code. It doesn't matter what language we use. Well, my answer to that is very simple. Well, if that's the case, let's all go back to using assembly language programming. It'll make life easier for everybody. We won't have to have compilers and things like that. But programming language and programming technology is fundamental to getting things right. And I think that is one of the fundamental things about Erlang. When we actually worked with Erlang, we knew what application we were trying to do. We knew that we needed distribution. We knew we needed concurrency. We knew we needed fault tolerance. And we knew we wanted things to be as concise as possible. So we were very fortunate, and we've actually been very lucky, because the application area that we had way back nearly 20 years ago now, the application area that we had then actually matches very well to the current modern multi-core and applications that people do today. So I think that Erlang got it right was more luck than judgment. We actually happened to be working on the right thing, and it's not only, and that was. I can't say we got any credit for predicting the future, but the future maybe predicted us instead. Quality is obtained by testing. Don't let programmers spend too long time coding. I've seen that before. We have a sort of code stoppers this time. If you haven't finished by then, you'll deliver whatever happens, and we'll test it and test it and test it and do it until it works. That happens all the time. And it's also a disaster, because if you've got a badly designed system to start with, if you've got badly designed code, no amount of testing is going to make the bad design go away. You have to get it right to start with, and if you haven't got it right, you have to redo it. Testing is very important. Don't knock testing, but don't think that you can actually tell programmers, oh, it's about time you give up now and start testing your stuff, make it work. Another thing that I found at one stage, and this was another disaster from Ericsson at one stage, they found that a lot of programmers were leaving all the time, going somewhere else. Well, it's quite natural they're going somewhere else. They got better paid somewhere else. But that was a sort of philosophy the management didn't understand. So they got the idea, well, let's employ a lot of mediocre programmers. Now, we're going back now 20 years, so I can say this sort of thing. I can say quite frankly that management in Ericsson is a lot better nowadays. They've got to get things right. But 20 years ago, the idea was, let's employ mediocre programmers, because programming is a very unintelligent job. You don't have to worry about that. And if we employ mediocre programmers, they won't leave. Well, if you employ mediocre programmers, you get mediocre systems. And that was actually, thank goodness, a very short phase in Ericsson history, but caused a lot of turbulence later in Ericsson. As the problem is, how do we get rid of all these mediocre programmers? Yeah, another one. Yeah, we also had armies of systems people, and systems people. Oh, okay, they don't have to sort of understand software technology. They just load a lot of bubbles with arrows going between the bubbles. And I remember one systems person designing something incredibly object-oriented, and his object actually had to be suddenly realized it had to be divided into two programs each on one processor. That suddenly dividing something and producing concurrency without realizing you have concurrency can be a major problem. And the systems person didn't realize that. This is why, again, I think that something like Scrum, when you actually mix together the systems people, the testers, and the people writing code into one group, and hopefully into the same person, the same people, that's why it is so very important, and it's the only way to go for the future. A lot more stupidity I could go on for hours and hours. Buy me a beer later and I'll tell you more about it. Well, oversimplified idea about how it works. This is very much oversimplified. That you notice this is not really a waterfall, because all the boxes sort of go into each other. First thing you do is specify as much as you can, and you can't specify everything. And then you find out more detail as you design. There's nothing wrong with starting programming on day one before you've actually specified anything. There's nothing wrong with that at all, as long as you realize you're probably going to have to throw away what you've actually done. It's a good way of finding out what needs to be done in a lot of cases. Well, as you go down the ladder and you do more programming, you find out more and more, and you're progressively adding more and more to your specification. No specification is perfect in the beginning, and no specification has got all the details. And at the end of the day, you hopefully get feedback from the customer telling you if this is what you wanted or not. But there again, you shouldn't leave that to the end of the day. So why is this oversimplified? Well, you need experimental programming to work out how to do the difficult bits. And quite honestly, the best thing to do if you've got a difficult program is to guess what are the difficult bits? What are the algorithms that are very hard? And these are what you should be working on to start with, because if you can't work out those right, you can't say, oh, we'll do the easy bits first and then do the difficult bits later, because you might find you can't do the difficult bits and you have to change things around. So programming early, but you have to be prepared to scrap what you're doing. On the other hand, you also sometimes need to start programming and produce something very rapidly to show the people that are paying you that you're actually doing something which they want. And sort of sitting down and specifying for days and days and days and then sort of finding out that that's what you want is that. So there again, it's sometimes essential to program at the beginning, produce a system, produce a prototype, and then the important thing is throw away the prototype and do it properly. The number of times I've seen prototypes turned into products and not very good products is considerable. Testing, people knock testing, people forget about testing. And they sort of find out you have to work out from the very beginning, how am I going to test my system? Because if I don't know how I'm going to test it at the beginning, then it's going to be very difficult to work it out later. So testing is very, very important. We've got that wrong a lot of times. We found that if you get that wrong, you're going to find you're spending yourself a lot of time testing, and you're going to find a lot of bugs that you don't find. User interfaces, you have to do that by prototyping. There's no other way than to make a user interface, show it to the customer, and say, is that what you want? Does it work? Is it usable? Test it, and get it right. If we look at sort of, I think the people that sort of originally designed Emacs probably didn't know about user interfaces. On the other hand, Emacs, once you've actually learned them, it's absolutely wonderful. I hate this modern version of Emacs. It's got all sort of push down menus and all the rest of it. I mean, why can't you just know normal keystrokes like the sensible people? But I'm old. Let's forget that. Rework. You have to be prepared to rewrite your programs, and you have to make sure that you go on doing so until you're happy with it. Of course, if you have Robert, he can rework things forever. But this is a dream that some people have had. I've seen people actually give lectures about this. I call this the specification dream. That you make a complete specification, you do an automatic code generation, and then you deliver it to the customer, and everything works and everyone's happy. There are people that really believe this, and it's very strange. I won't quote names. I have some people that I know very well that have this idea. The main reason this doesn't work is you cannot define things in detail. You cannot write a complete specification in the beginning. And if you could write a complete specification, it would be the program. You wouldn't need to. And that's why the whole process, this is a fundamental thing which people believe, and it's fundamentally wrong, and it always will be wrong, and it never will be right. The idea of formal specifications, the idea of generative code from specifications is fundamentally wrong, because that's not the way we work. And then we have the modeling dream. Oh, I hate the modeling dream. I had about 60 people working for me at one stage that sort of made models in UML, and they sort of made all these boxes and funny symbols with arrows and things going in between them, and they sort of programmed, and they forgot the little detail that in the boxes, some of the boxes, you actually have to write some code. Because UML is basically flawed, because you cannot have something which is two different paradigms. We're writing C++ code or Java code in boxes and a completely different semantics and syntax for the UML. It's completely horrible. You can't generate a complete system from a modeling language. If you could, it wouldn't be a modeling language, it would be a programming language. And if you're going to use modeling, the question you have to ask is the modeling language easier to work with than the programming language? And my experience is that it usually isn't. It's usually harder to work out what the modeling language is supposed to do than it is, for example, starting writing the Erlang code to start with. And in that case, why are we bothering? Why are we doing that? The other problem with modeling is that you have to go backwards. At the end of the day, when you have a system which is getting nearing completion, you're going to make changes in your code. And unless you can actually go backwards and make corresponding changes into your model automatically, then the model is going to become out of date and totally useless. A high-level model can be good. Some form of model of boxes and things to explain to people how things work can be a very good idea. So high-level models, don't knock them, but remember, it has to be a high-level model. And remember, you're not going to generate anything from it because that's a bad idea. The other important thing to remember is the people who make the model should be the same people as the people who are actually doing the programming. You shouldn't actually try and have modelers and programmers in separate groups. I tried that. Teams, how do you make a team? Well, going back to my original picture again, that developing something for the first time, small team, excellent domain knowledge, excellent software knowledge, doing again several small teams, software technology ability is the most important part of that stage. Get these teams right, make sure you're right. And again, as I said earlier, if you start with team number 1, go to team number 2, and then find you got it wrong and have to go back to team number 1, then you're in deep shit. That maintaining a product, small team again, and then you need these special people with funny minds to get it working. Starting with the wrong team is a disaster. Adding more people doesn't make a project go faster. A bit about programmers. Again, that's what I really hate when I look at the paper is to see the fact that people actually put advertisements in the papers saying, "Oh, I want a Java programmer, I want a programmer that knows this technology or know that technology," or something like that. That is fundamentally wrong. A programmer is a programmer. A programmer who can't learn Erlang in 2 weeks, don't employ them, because you can learn Erlang in 2 weeks. It's easy. Okay, the syntax sucks, but Elixir maybe will do something about that. Let's hope so. Yeah, but syntax isn't everything. I think Robert went out. The ability of programmers is hugely different. At one stage that I was involved with the HR department, you know, HR stands for Human Resources. I came to the conclusion that the HR department was neither human nor were they resources. But I was involved with them to try and devise a test to get programmers to employ what we should use to get good programmers. And we employed some psychologists and all sorts of people, and they tried to say, what is the characteristic of a good programmer? What's the we actually have to ask them? What's the question we have to ask in interviews? And the only conclusion that these group of psychologists came to was that programmers are usually a sort of the most common characteristic of all is they're usually bolshily minded and bloody minded individuals who want to do what they want themselves. That was the only thing they could do. That most programmers, good programmers, are individualists. Some programmers are good at doing things, some programmers are not. A fundamental fact, and it always surprises me this, is the majority of people in this world today aren't programmers and never will become programmers and cannot program. It requires a special mindset to become a good programmer. And you have to realize that most people can't do that. It's just like advanced mathematics or playing good chess. Most people can't become a sort of excellent chess player. Most people cannot become a sort of advanced particle physicist and all the mathematics involved. I can't. But most people cannot become programmers. And you have to remember that. So that if you're all sitting here, and I'm sure you're all good programmers, feel immensely proud of yourselves so you've actually managed to sort of write one line of code and get hello world to work. Employ good programmers. Okay, Erlang is easy. A good programmer can learn Erlang in its environment in a couple of weeks. I think that's one of the best things about Erlang. It's an incredibly simple language. That people don't realize that. It takes you months to understand what ampersand C++ actually means. That in C, programming. I probably programmed more C than I programmed Erlang. But every time I go back to Erlang, I sort of think, oh, thank God for that. I mean, every time I try to work out what pointers do in C, it requires a sort of mental revision, which takes about 5 minutes before I get into sort of C programming mode again. But I find I can sort of program Erlang fairly fluently. Usually understanding the application domain is actually harder than understanding the programming language. That is the difficult bit. The real difficult bit about programming is finding out what you're supposed to do and how it works. And that's really, if you want to employ people who know about various things, don't put advertisements saying in they want to know, you can tell them you want them to use Erlang in the advertisement, but that's quite important. But you have to make sure they actually know the domain that you're working in. That's actually most important. And if you actually want to test for someone writing for employing a programmer, just ask them to show some code that they've written themselves and ask them to explain it. That's the best test for employing programmers. If they can't explain their own code, then they're in trouble. Maintenance, I said, there again, many programmers prefer to do new things. Software maintenance isn't cool, but it's very, very important. So if you're employing a programmer, use your junior programmers for maintenance. It's a good way to introduce them. But make sure that you have experienced programmers watching over the junior programmers so they don't mess up the system that you're going. They get it right. Don't let them change things on their own account, and make sure you review what you're doing, or else they'll mess up the system for you. And there again, if you're going to be able to maintain your code, you must insist that it's properly documented and commented. Programmers that don't do that, don't employ them. However good they are, whoever they can't explain their own code, they can't document their own code, don't employ them, because you're going to land up with a mess if you have them around. Very strange that people don't realize that actually writing comments and explaining your code is about 5–6% of the job, and it's easy to do. So don't employ non-documenting programmers. Bugs are natural parts of programming. You should be happy when you find a bug. You should say, hooray, I found a bug. This is great fun. I wonder how that happened. If there are a lot of bugs in one part of the system, don't start blaming the programmers. Find out why. Maybe you've got a bad program on that part of the system. Maybe that's a very, very hard part of the system. Find out why and look into it. Don't start by sort of blaming the programmer. Now, why does Erlang help? Why is Erlang good for all this? Because I've been talking a lot about sort of programming. I haven't been talking much about Erlang. Well, that's because programming is an iterative process. It's an iterative process is a better way than saying trial and error, because it's a name for intelligent trial and error. Erlang actually suits an iterative development process very well. It's short, expressive code. You don't need to change a lot for each iteration. Dynamic typing is actually very good. A lot of people would say don't like that, but it certainly makes life easier for you without having to write a huge amount of type declarations when you change things. Changing code in running systems, that actually, we did put that in because we thought that was needed because we were making telephony systems, and telephony systems can't go down. But in point of fact, it has other applications you don't really think about. That changing code in running systems means that if you're testing and you find a bug, you can correct that bug and put it right without having to road things. You don't have huge build times. It means that you have a very much faster turnaround time between your find the bug, correct it, and do it again. Simple concurrency and distribution. There again, we did that because our application needed them at the time that we needed them, and that's come in today. I think one of the best compliments that we've actually had for Erlang was Scala, which used Erlang's distribution. Okay, there are a lot of other things which I don't like about Scala, but Scala's communication mechanism copies Erlang, and I like that. I think that copying is probably the sort of best form of recognition. There are a lot of good tools nowadays. When we first started, there weren't, but there are nowadays. And the let it crash philosophy, separating failure recovery code from application code, makes life a lot easier. Now, I actually made this last slide this morning because I thought that I'd better talk a bit about my experience of Erlang Coder. That when you start people on Erlang, you start a new project, the first thing they said is, why are we not using C++, Java, or something like that? And they don't really realize that the reason we're doing that is simply because we have a better paradigm. And people don't like change. There's also resistance to change. People believe that functional programming is difficult. That if you've been brought up with iteration and you actually have to go into recursion, it requires a mind shift, but it's not a difficult mind shift. Syntax is weird, we know that, but if you're a Prolog programmer, you're all right. If you're not a Prolog programmer, you have problems. That what happens after that, the first stage, when we start a project, the first thing happened is some people run away. That's to say, don't like this, do something else. Well, I'll say, if they run away and they don't like you, wave them, bye-bye, thank you. Your paycheck is to the corner, go, get out. Some people try to program, and the majority of programmers do it well. There's some people that still try to program C++ in Erlang. That's a bad idea. That I had a group of people once upon a time, actually once I wasn't managing them, that changed Erlang to be object-oriented and changed the error handler to be able to have some form of inheritance in the system. That was an awful mess. But then the majority of people, and maybe a goodly number of them, actually enjoy it. And they find that Erlang is easy and fun to work with. And see that time and time again, that when I visit old friends working for Ericsson, and a lot of people that were doing something else, maybe they're doing DSP programming, or maybe they're doing something that Erlang isn't suitable for, they come to me and they sort of say, oh, I did enjoy that Erlang project, I'm looking for a new one. A lot of people really, when they actually start embracing Erlang, really like it and want to go on using it. Programming, what, why, how? Some programming iterative process, a large amount of trial and error to find out what needs to be implemented, why does it need to be implemented, how should it be implemented. And I find that Erlang is actually very suitable for this sort of iterative development, especially when you have concurrency and distribution. I'm struggling for the moment. When I retired, I decided I'd take up Erlang programming again to a larger extent. And I decided the one thing I had to do was organize all my digital photographs, thousands and thousands of them. And instead of using Picasso or something which exists already, I said I'd have to write that myself. I've gone quite well. I discovered Monesi was a bit strange. I had not used Monesi as much before, but I worked that out. But I've got onto the graphic programming. I find that if anyone really would like to do me a good service, they can write a little manual about how you actually use WX widgets in Erlang, because I can't figure it out. Erlang's fun. If you don't think Erlang's fun, why are you using it? If the people you're working with don't think that Erlang's fun, you're working with the wrong people. So Erlang's fun. Enjoy yourselves and have a nice conference.